I did my observing project on the deep sky object NGC 6826. NGC 6826 is a planetary nebula. A planetary nebula is a stellar remnant that occurs after a star has undergone the red giant phase and has expanded off all of its outer layers. A planetary nebula consists of a central white dwarf, which is this hot, compact core remnant of a red giant, and a layer or layers of outer gases which the red giant had expanded off. This particular planetary nebula has a relatively bright central white dwarf with an apparent magnitude of 10.6 and a mass of 0.65 solar masses. It's called the blinking planetary nebula because we can't see it head-on, but we can see it through a peripheral vision, hence giving it a blinking effect. The nebula is a few thousand years old and is 2,200 light-years away. It is an emission nebula because the gases, which are hot, are ionized, and ionized gases are able to emit photons. The nebula has a relatively low helium, nitrogen, and carbon content, with the nitrogen and carbon content being similar to that of the Sun, but lower than other nebulae. The gas surrounding the star is divided into 3 layers. There's an inner layer, which is very hot and therefore emits very brightly in the X-ray region, a relatively dense middle layer, which is bright green, and a less dense diffuse outer layer, which is a darker green. The presence of an outer halo indicates that the inner nebula was formed rather late in the evolution of the star. Here are some images of my object that I obtained through the GTN telescope. This is an image in the red filter. This is an image in the green filter. It was very interesting that neither the red filter nor the green filter had anything that was red or green. Here's an image in the blue filter. Here's an image in the clear filter. I wonder why the background is so brightly yellow in the clear filter. And here's an image with specialized effects. I'm very interested to see what these speckles are and why they appeared in this picture and not any of the other images. We can learn a lot of interesting things from this planetary nebula. First of all, the fact that it's a planetary nebula can tell us a little about the nature of the interstellar medium. The way that the planetary nebula expands and the rate that it expands at can tell us about the density and distribution of matter in the surrounding interstellar medium. In addition, this planetary nebula has some pretty particular unique features. First of all, it is rare for a planetary nebula to have 3 layers, but this is one of the few that does. There are only 2 other planetary nebula that have 3 layers. Our current models of stellar evolution cannot explain the 3 layers of the planetary nebula, because most planetary nebula have 2 layers. Therefore, if we can figure out what causes these 3 layers, we can possibly be able to determine and perhaps even modify our theory of stellar evolution and make appropriate necessary changes. However, the most unique and noteworthy feature of this planetary nebula is the presence of flyers. Flyers is an acronym for Fast Low Ionization Emission Regions. These flyers appear to be moving inwards, as we can tell from the shape of these wakes, but that doesn't make any sense, since the rest of the planetary nebula is moving outwards. We scientists have not found an explanation for this, because the 2 possible explanations, high-speeding bullets shooting through the nebula and photoevaporated gas sucked into head-tail shapes, fail basic tests. In addition, these flyers seem to be moving outwards horizontally at speeds greater than the speed of sound, faster than the rest of the material that's expanding outward from the nebula. These flyers have low ionization in comparison to the surrounding gas of halo, suggesting that ultraviolet radiation isn't able to penetrate them. Scientists are still hoping to find an explanation for flyers, and discovering what exactly these are and how they're caused could be a very interesting new scientific discovery.